They say that caching is one of the hardest problems in software engineering, and I think it's safe to assume that distributed caching is even more complicated. Now, what do you think happens when we introduce two-level caching and cache invalidation into the mix? Let me explain. So let's first understand the problem that we typically use caching for inside of our .NET applications. Let's say we have an application server and some sort of database where we are storing our data. 90% of all of the applications that we make are some form of CRUD, where we try to access the database to get some data. Now, depending on how much data we are dealing with, this operation could be relatively expensive. So in order to make this faster and not have to incur the cost of a database query, we introduce another component that we call a cache. So now our flow turns into, is this data in the cache? And if it is, we can just return it from the cache. Otherwise, we get some data from the database, plus we store it in the cache, so that the next time when we try to retrieve this, it's available inside of the cache. Now, on a high level, you could have two types of caches, what I'm going to call L1 and L2. An L1 cache is typically going to work in memory, whereas an L2 cache is going to be distributed. Now, inside of .NET, for the in-memory version, we have a couple of abstractions, usually an iMemory cache as the default implementation. And when it comes to a distributed cache, we have many implementations of the iDistributed cache interface. And usually these are going to use some sort of external storage, typically Redis, or you could even use Postgres or any other database that implements this interface. Now, what's also interesting is that starting from .NET 9, we have a new abstraction called a hybrid cache that implements both an L1 and an L2 cache inside of the same abstraction. Now, if your application has just one application server and a single database and cache, you probably won't run into too many issues. But where this becomes problematic is when you have, let's say, multiple application servers and you're still using one database and one cache behind the scenes. Each of our application servers is going to have a local in-memory cache, what we would call the L1 cache. And we have to note that the L1 caches are separate from the level 2 cache, which could be something like Redis. Now, if you are using something like hybrid cache, you could run into a situation where you access something on the first application server. It doesn't find it in the cache, so it reaches out to the database to fetch this value, and then it's going to store it inside of the L1 cache, but it's also going to store it inside of the L2 cache. So now what happens is you have this on your first server, but not the other three when it comes to the level 1 cache. Now, if your next request lands on the level 1 cache, you're going to run into a cache miss on the L1, but it's going to find a cache hit on the L2, and it won't reach out to the database to fetch this data. And the same happens when you reach out to the other application servers. So eventually, these values are going to sync up, and everything is going to work fine for a given period of time, depending on how long your cache duration is. Now, let's say we get some update in the database, and this forces us to also invalidate the cache. Let's say, again, we have an invalidation from our first application server, going to write some value into the database, and then is going to attempt to invalidate the L1 cache and the L2 cache. Invalidating the distributed cache is going to work fine, so is invalidating the L1 cache, but the problem that we also have to solve in a distributed system is invalidating the level 1 cache in all of the application servers, regardless of how many of them we have. So to do this, you need some sort of communication channel between your application servers. This is typically called a backplane, and all of our application servers are going to connect to it to facilitate the communication between them. Now, to make this a bit easier to digest, let me move the backplane over here. And what we want to happen in case of a cache invalidation event is our first application server sending some sort of message to the backplane, and then the backplane has to take care of notifying the other application servers that they should also clear their level 1 caches. Now, as of recording this video, the official hybrid cache library does not implement this, so I'm going to show you a simple way of how you could implement a backplane yourself using just Redis and the Stack Exchange Redis library. So here's my setup in the Aspire app host. I'm adding a Redis resource and I'm configuring my API with 5 replicas. So this is going to help us test out invalidation across a multi-node scenario where we have multiple level 1 caches and one level 2 cache. Inside of my .NET application, things aren't going to be too complicated. we have a service registration adding the hybrid cache, and I have different expiration times for the local and distributed cache on purpose, where the local expiration time is going to be 1 minute and the distributed one is going to be 5 minutes. So this can be helpful if you don't want to use a backplane, but it kind of just masks the overall problem without solving anything. You can make this shorter if you're concerned with the local cache running out of sync, and in the worst case scenario, this can be just a couple of seconds, let's say 5 or 10 seconds. And in this case, you're just using a glorified level 2 cache, where the level 1 cache gets rarely used. So how you really want to solve this is with a backplane. And for this, we can use Redis and the channel communication mechanism that Redis implements. It's basically a publish-subscribe mechanism where you can fire off a message and it gets fanned out to any existing subscribers. And a simple way to implement this is using a background service. Now, as far as my public API surface goes, I've got 2 endpoints. I'm using the hybrid cache abstraction, which exposes a get or create async method. And in case of a cache miss, I'm going to call out to an external service to fetch the information that I'm looking for. And after this completes, this value will be cached for a given period of time. I also have a delete endpoint, allowing me to test out cache invalidation, and this is going to get my subscriber using a connection multiplexer and is going to publish a message to a Redis channel that I called cache invalidation. The value that we're going to publish is just going to be the key that we want to invalidate. Now this is a little inefficient. I'll explain why in a moment. Now let's take a look at our background service. So here we again need the connection multiplexer, which you can just add as a singleton service and then use throughout your application. And what's going on in the execute async method is we are subscribing to any messages that come from this cache invalidation channel. Our callback gives us access to the channel instance and the key that we are going to use for invalidation. And in this case, I'm using hybrid cache to remove this value asynchronously, which I'm also doing in the delete endpoint, which you can see here. And this is why I mentioned a slight inefficiency in this implementation for 2 reasons. First is we're going to call remove async on the level 2 cache twice, where we are really only concerned with removing this from the local cache. So if you want to ensure that you only remove this from the local cache, you can inject an instance of the iMemory cache. In here, you can comment out this code and you can say memory cache remove and just passing the key that you want to invalidate. This is going to achieve the same result. And the second inefficiency appears because of how Redis channels work. When you publish a message to a channel, it's going to be broadcast to all existing subscribers, which means the same service that published this message is also going to consume it. So what you could do is assign some sort of unique ID to each publisher. And when you consume this, you can check if you are consuming your own message. And in that case, you can just ignore it. Now I'm going to go back to the previous implementation because it's going to generate some distributed traces for us. And let's run this. You're going to see the Aspire dashboard spin up, and we have our Redis instance and 5 backend instances of our Movies API. Now I'm going to jump over to the distributed traces view, and on my second screen, I'm going to fire off a couple of curl requests. I'll start by sending a GET request to fetch a movie from this API, and you can see a distributed trace appear, and a few moments later, a couple of additional traces, which represents storing the result of this API call in our Redis instance. We know this was a cache miss because there's a trace here reaching out to the external service to fetch the data. Now, if I call this again, you can see that we don't have a trace for the external service because we can satisfy this endpoint from our cached value. So if I call this a couple more times, you can see some additional traces show up, and occasionally we're going to also see a request to Redis because we landed on a different API instance and we have to populate the L1 cache. Now, if I go ahead and invalidate the cache key for this movie, you'll see that we have 5 traces show up here, and this is our background service running behind the scenes, consuming this publish here and processing the message from a Redis channel where we execute a remove operation in the L1 and L2 caches. If we take a look at the structured logs, you can also see the logs from our background service on each of our API instances stating that we are clearing a cache for a given key. Now, if you don't want to write this code yourself, you can always use an existing solution, and one of those that I recommend is Fusion Cache, which also has a hybrid cache implementation, so we can still use the hybrid cache API surface while leveraging the Fusion Cache implementation, which is more feature complete in my opinion, and also supports a backplane that you can plug in using Redis, and is going to implement more or less what I showed you right here. If you're interested in learning more about building distributed systems, I recommend checking out this video next. If you enjoyed the video right now about cache invalidation in a distributed scenario, leave this video a like. Thanks a lot for watching, and until next time, stay awesome.